Hey guys, thank you so much for watching the virtual coach. In this video, I'm going to solve some of the important numericals based on the chapter called electricity. Okay, so this video will be for 10th standard, so those are going to appear for their board examination. So first we'll begin with the basic formulas that we must know before solving the questions. Is that clear? So first we'll discuss about the electric current. So what is electric current? So basically, I is equal to Q by T, where current is defined as a rate of flow of charges, right? So I'll write Q by T, where T is the time and Q is the charge, right? So here, what is the SI unit of the electric current? Here, ampere. So AMPERE is a SI unit of electric current. So you may write that A, right? So this is what the basic thing that we must know about the electric current. Now, if we move to next part, here we'll come across the Ohm's law, right? Ohm's law. So, which is given by V is equal to IR. So, what does this mean? So, basically, whenever there is a conductor, if this is a conductor, so the potential difference is directly proportional to the current flowing through the conductors, right? So, or you can say that the current flowing through this conductor is directly proportional to the potential difference across its end, right? If you remove this one, you can write as I is equal to, or V is equal to IR, where R is the resistance that is offered by the conductor. Is that clear? So here R is the resistance, so you can write V is equal to IR as a normal form for the Ohm's law. So we'll get lots of numericals on this formula. But guys, we must know that what is the importance of potential difference here. V is equal to IR. So what does this V represents? So whenever there is a conductor, if this is a conductor, so we know that there has to be any potential difference, right? If this is a conductor, there has to be potential difference to flow the current in it. So if I'll say here it is 10 volts plus 10 volts and here it is 0, so what is the difference? It is 10 volts, and that causes the flow of current. And in case if you take 2 amps here, so if there is a potential difference of 10 volts, so there is a flow of current that is 2 amps, right? Again, if I increase the potential difference, if this is a conductor again, if this is 20 volts, so there will be flow of current that is 4 amps. So what you can see here, the potential difference is directly proportional to the current flowing through it. Clear? So this is what the basic idea that we must know about the Ohm's law. Now we'll talk about the factors which affects the resistance. Here, the factors affecting resistance, right? So I know that resistance is directly proportional to the length of the conductor. Again, it is inversely proportional to the area of cross section of the conductor. Here, if I take this as a equation 1 and this as 2, so if I'll join these two, so what I'll write, R is directly proportional to L by A. So if I'll remove the proportionality constant, I can write as R is equal to rho L by A, where rho is called resistivity. Is called resistivity. So even this is also very important formula. So basically R is equal to rho L by A. So this is a very important that you must know for solving the questions. Is that clear? Where L is the length of the conductor, or A is the area of cross section of that, and R is the resistance that is offered by that. Now further we move one of the most important topic, so that is resistor in series and resistor in parallel. So we know that whenever there is an end-to-end connection or an end-to-end connection, we'll say it as a series. So if this is the resistor and across A and B, so R1, R2 and R3, so this R1, R2 and R3 are said to be in series, right? If it is in case of parallel, so we will write like this. So again you can see here this R1 and R2 are in parallel because they are connected across the cement. Is that clear? So this is what the basic idea that we must know to identify whether the resistors are in series or in parallel. And also guys, one of the most important thing that we must know while solving the questions, so wherever there is a resistors are in series or in parallel, what divides what remains same. So here we must know properly. So if I take to the parallel combination, right? So for example, if I take again the resistors like in parallel, so this is R1, R2. Yes, now we move to the resistor in series. So if I write a circuit diagram here, so there must be three resistor. Is it visible? Okay, yeah. So 1, 3, right? So R1, I'll write here. So R1, R2 and R3. So these are connected across the battery. Okay, so this is plus, this is minus, we know that. Now what is the effective resistance? This is the first formula that you must know whenever the resistors are in series. So I'll write as Rs is equal to R1 plus R2 plus R3 if it is three resistors are in parallel. Clear? Now whenever the resistors are in when it is in series. Now whenever the resistors are in series, what divides what remains same, that you must know properly. So here, when resistors are in series, voltage divides. What divides? Voltage divides. That means potential difference divides, whereas current remains same. Current remains same. So you can see here, when the current flows in these directions, what happens? There will be same current throughout the circuit. If it is A and B, there will be same current throughout the circuit, where the voltage divides V1, V2 and V3, where I can write the effective voltage is equal to V is equal to V1 plus V2 plus V3, where V1 is the potential difference across R1, whereas V2 is the potential difference across R2 and V3 is the potential difference across R3, and so on. Right, so this is what that you must know properly. Right, next, if we move to the parallel combinations, you can see here there are three resistors R1, R2 and R3. Right, so if I'll connect this to a battery, okay, so in this what happens, the effective resistance of this three resistor, so you can write as 1 by Rp, where P is parallel. Okay, resistance, effective resistance in parallel. So 1 by R1 plus 1 by R2 plus 1 by R3. And in this case, what divides what remains same? So here the current divides, right? So I divides, whereas V remains same. Clear? So if I want to know the effective current that is flowing through this circuit, so what I can write, if this is the current, right? So while it comes here, it's going to divide the current I1, I2 and I3. So you can see how the current is dividing, whereas the potential difference across all these three will remain same. So what I can write, effective current or the total current flowing through the circuit, I is equal to I1 plus I2 plus I3. Okay, so this is the thing that you must know properly, right? Now we'll revise what and all we read till now, and I'll write the formula in one page so that you must just copy in your textbook or somewhere in your notebook, right? So first we read about the current flow, right? So I is equal to Q by T. So this was our first formula, and the second formula was Ohm's law, which is V is equal to IR. Then the factors of affecting the resistance, so R is equal to rho L by A. Then resistors are in series and parallel. So series, what happens here is RS, effective resistance, is equal to R1 when three resistors are in series, R1 plus R2 plus R3. And for example, there are n number of resistors, then you can write as plus up to n. Now here what happens, in series the current remains same, right? So I is equal to same, whereas V is equal to V1 plus V2 plus V3 if it is three resistors and in parallel. Now this was for series. Now we move for the parallel. So here parallel, what happens here is R1 by Rp, the effective resistance in parallel, is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Got it? Next, what happens here? The current divides, we know that. So I is equal to I1 plus I2 plus I3, whereas V remains same. V remains same. So these are the formulas, right? So that you must know while solving the questions. These are the main basic formulas. Now we'll move to the most important topic, that is heat, power and work done basically. So guys, now we'll just discuss about the power. So power is basically P is equal to VI. So that is potential difference into current that is flowing in a circuit. So also you must know that V is equal to IR, right? This is from Ohm's law. So I'm going to use this formula in this, so to get a different forms of power formula, right? So P is equal to, what is V is equal to IR? So I can write I square R, right? So this is one form of power. Now again, if I'll solve here for I is equal to V by R, right? So again, if I substitute this in this equation, so P is equal to V square by R square into R. So your R get cancelled, or one R will remain, so which is basically V square by R. So P is equal to VI, one form, okay, this one form, and P is equal to I square R, this is another form. P is equal to V square by R, this is the third form of power. So you can use either of these formulas so that you can solve properly with your numericals. So you can use based on the condition that they have given the question in any of this formula, okay, that you can see here, 1 2 3. Got it? Now we'll move to the heat, okay, which is also very important, and lots of numericals that we can expect from that. So guys, basically heat is nothing but H is equal to power into time. So here we know that P is equal to VI, right? But if I'll substitute this P is equal to VI in this equation, what I get, H is equal to VIT. So this is one of the important that you must know properly, right? Where to use, how to use, based on the values that they have given in the numericals, they will use this formula. Got it? Now we'll move to the important numericals that they have asked in previous question paper. Along with that, we'll do some example to clear with the concept. So we'll do this question, which is basically based on the flow of charges. So here they have asked that a current of 0.5 amps is drawn by a filament of an electric bulb for 10 minutes. Find the electric charges that flows through the circuit. So here, always you must write the given. Here I is equal to 0.5 amps. T is equal to 10 minutes, that you must convert to seconds, that is 10 into 60, so that is 600 seconds. Again, Q is equal to question mark, that is what we have to find. So you know what guys, always while solving the numericals in examinations, always please write this given. At least if you don't know anything, at least write this given, so that you must get half marks also, okay? So this is very basic. So we know that current is equal to flow of electric charges, right? So if I want Q, so I can write Q is equal to what? IT. So they have given I, we know T also, so Q is equal to 0.5 into 600, so which is nothing but Q is equal to 300 coulomb, where coulomb is a unit of charge. So very simple. So this was a question basically for 2 marks, okay? So you can solve it easily. So now this is another question. So basically they're asking, so 2 lamp, you can see here, the 2 lamp, one rated as 100 watt at 220 volts, and the other 60 watt at also 220 volts and are connected to parallel electric supply. What current draw from the line if the supply voltage is sharply 220 volts? You can see here, right? So what they're trying to say means there are two lamps. You can see here. So there are two lamps which are connected in parallel to each other, and again there is a source of electricity. Here you can see, and this one is rated as 100 watt and this one as 60 watt. Okay, now they're asking what is the current, and one more thing, this is 220 volts. Okay, the potential difference between those two is 220 volts. So they're asking what is the current that is drawn from the this source, right? So we know that, guys, here we know that P is equal to VI. So power is equal to potential difference into current. So they have given a power P is equal to 100 watt, V is equal to 220 watt, and for bulb 2, this was for the bulb 1, this was for the bulb 2, P is equal to 60 watt and V is equal to 220 watt. So we know that from our previous lecture that whenever something which is in parallel, whether it is resistor or the bulb, what remains same here? The voltage remains same. So this 220 and 220 will remain same. So I can write that. So if there is a two bulb 1, bulb 2, I have to take case 1, right? So for case 1, P is equal to VI, but I want what? I. So I is equal to P by V, correct? Now what is P for bulb 1? It is 100 watt and V is 220. So if you divide that 100 by 220, what do you get? We'll get 0.45. This is what we get. Now this is for bulb 1. Now for bulb 2, we move to case 2. So again I is equal to, this you take I dash, I double dash. So again P by V. So what is P again? It is 60 watt. You can see here. 60 by again 220. So what is 60 by 220? It is 0.27. Is that clear? What is that answer? 0.27. Now this 0.27 and this 0.45, if I'll add these two, so this is the final current that is drawn from the source. Clear? So what we get the final answer? So that is 0.27 plus 0.45. So it is 0.727. And so this is the total current that is drawn from the source. Clear? So this was a very simple question. So I hope you understand this one. Yeah, so this is our next question. So what they're asking is, calculate the number of electrons constituting 1 coulomb of charge. Okay, and they have given charge of 1 electron is 1.6 into 10 power minus 19 coulomb. So guys, we know that Q is equal to N. This is the basic formula that we know about the relation between the charge and the number of electrons and the unit charge of electrons. So here we want to know that the number of electrons constituting 1 coulomb of charge, right? So they have given already charge of 1 electron is 1.6 into 10 power minus 19 coulomb. So we can solve here. And one more thing, here Q is the charge of the electron, N is the number of electron, and E is the charge of 1 electron. So if I want to know for N, so N is equal to Q by E, right? So I can write Q already they have given as 1 into 10 power minus 19 coulomb. Clear? Now I want to know the N, how many electrons that contain. So 1 by 1.6, what is the answer? So it is 0.625. What is the answer? 0.625 into 10 to the power of, or 10 to the power of 19, right? But I want what in terms of 4 significant. So I can write 6.25 into 10 to the power of 18 electron, right? So N is equal to 6.25 into 10 to the power of 18 electrons. So this is what the answer that you must get for this question. Now guys, this is the another question which are also very easy. So what they're asking, an electric iron of resistance 20 ohm, okay, 20 ohm takes a current of 5 amps. Calculate the heat developed in 30 seconds. So guys, they have given is R is equal to 20 ohm and current is equal to 5 amps and time is equal to 30 seconds. So we know that power is equal to VI, and again V is equal to what is that? V is equal to IR. So I can write I square R. Clear? So what I'm trying to say is, if P is equal to VI and we know that V is equal to IR, so what this equation becomes? I square R, correct? So again we know that H is equal to what they are asking, calculate the heat developed in the electric iron. So H is equal to PT, that is power into time. So we know that P is equal to what? I square R. So I square R into T. So this is what we must know. Now H is equal to I square. What is I? It is 5 into R is 20 and T is 30 seconds. So what is the answer? So basically H is equal to 5 square into 20 into 30. So what are you going to get? You're going to get 15,000 joules. So this you can also write as 15 into 10 power 3 joules. So this is what the heat that is dissipated or that is produced in the electric iron. Clear? So this was very easy question. So you may expect in your final examination.